All right, let's start. So as you can see on the screen, we have a CPEA Prescription Paper 18. So I'll be using this as a reference to go over some fundamental principles that should form the foundation for mathematics, foundational mathematics, basic mathematics, right? But I want to focus my attention on the area that many persons or many students and people struggle with, which is the translation between English language and the mathematical language or mathematics. Now, mathematics is a language on its own. So for example, look at this question here. This is the first question here, where a student will have to contend with converting between language art and mathematics. So how do you go about it? Well, the simplest way to do this is to just focus on the numbers. That's all. Focus on the numbers. In mathematics, we care a lot about numbers because that is the language of mathematics. Numbers and the rules between the numbers. And the rules between the numbers are operators. So before we jump into this question, let's just talk about this concept about mathematics. Now, general concept about mathematics. Now, mathematics is a language system that uses numbers instead of words to express itself. So instead of using the word 1, we would spell it as that symbol 1, all right? And that symbol 1 is what you would call a notation. Now, in English language, you would say, I have 10 mangoes and then I bought 10 more, and now I have 20. But in math, you just write it simply as what? 10 plus 10 equal to 20, because we're just focusing on the numbers alone. Now you can say 10 mangoes plus 10 mangoes equal to 20 mangoes, but it's just a repetition. We don't need the words. And without the words, we can get correct answers. And that's the reason why mathematics uses less words, or don't need the English or the language art words to actually effectively express itself. All right. So math, numbers, operations, and the equality sign. So numbers, everyone knows what numbers are: 1, 2, 3, 4, 5, and then you have the decimals in between, and then fractions. Knowing how to add those numbers is very, very important. Knowing how to add decimals is very important. Knowing how to play around fractions, very important. Addition, multiplication, and all that is very important. CPEA will focus on this a lot because they're foundational knowledge. The general rule is that always remember BEDMAS, and that will mean that you remember that you always deal with the bracket first: exponents, division, multiplication, addition, and subtraction. Now, the notations would be what summarizes the symbols that we use in mathematics, right? You can invent some as we go, and I'll show you how we use a notation that we would invent to solve that problem, or to solve subsequent problems that are similar to it. Now, this first notation, addition, is very important because it's used to do what you call addition operation in language art, right? So this symbol represents addition, and there are other words that it equally represents. It equally represents more, all right? Not more than, but more. It equally represents increase. It represents plus. So all of these words are words that are represented by the word, by the symbol. And so is this one here. This one actually represents subtraction, discount. It represents subtraction, discount, decrease, reduce. This could be used to represent those words. And then this one here is just multiplication, and it stands on its own, and then you have division. For multiplication, for division, it could equally represent the word share, all right? Share. Maybe there's one for multiplication, but I can't think of anyone now. So there are other symbols to think about. So you have this other one, which is the same thing for division. It's also used to represent division. This is this is greater than, because it looks like my right hand, and this is less than because it looks like my left hand when folded this way. All right, so you have the exponents, so raise to the power square, and then you have the e. No one bothers about e at this level, so let's forget about that. So I'm going to speak a little bit about this symbol here. It is going to form the foundation of everything you need to know as per the rules for algebra and mathematics as a whole, and actually the rules of knowledge of most epistemological systems. So when we say equality, we're saying that something is equal. Now we use the symbol equality sign symbol to actually represent the word equality, but equality means that something is fair or something is balanced. All right, so if we use the word balance, then I can borrow this idea from science, where you have a bench or a seesaw that is balanced at the middle, right? So if it is balanced at the middle, it is said to be balanced and equal. And if it is equal, then it means that you'll be violating this equality if you add any small weight here. By violating, I mean you'll be breaking the rule of equality by adding a weight here. Now, in order for this bench, seesaw, or these two students sitting here, this student here to be balanced, then another student must sit on the other side. So this is the right side, this is the left side with the same measure, with the same for the same mass. I almost said weight. And by the way, weight and mass are not the same thing. You have something like this where you have mass. So for example, one kilo means 1,000 grams, and that is a measure of mass, the amount of matter in a person. Weight, on the other hand, is measured in Newton, right? It's not just the amount of matter in a person, but it's the amount of matter and gravity due to that matter, or the gravity acting in a person. But coming back to this, so the rule of equality is simply this. If you have an equal to, this fulcrum here represents equal to. Everything on this side that you do on this side would be balanced by everything on this side if you do the same thing to the right side that you do to the right side to the left side. So if you remove something here, you must remove something here. And the rule is that whatever you remove must be the same as whatever you remove from the right side must be the same as what you remove from the left side for the rule to be not to be broken or violated. So that is the most important rule. And once you're not breaking this rule and you're applying BEDMAS, you could solve just any problem. You just have to remove the words from the expressions from the question, and then whatever is left should be the numbers, and then those numbers would work on their own to give you the solution. But there's one more notation, one more thing to add, and that thing is that when we do not know something, like we are speaking of a certain number that we don't know, we wish to know it, but it's a specific number. If that number is neither 0 or infinity, then it means that it's a finite number. We can use a box to represent that number. And now what the Arabs discovered 1,000 years ago, right, when they discovered algebra, is that if you create a box or you use a letter, it doesn't matter, all right, any letter at all, to represent that number, you could use these boxes, the box or the X or N, to solve problems with the same basic rules of mathematics as you would have used that number, and you will still get your answer. In this case, you could even use the box to figure out what that number is. All right, so we're going to go back to that example to explore this. So the rules of mathematics are still the same rules everywhere as the rules of language and the logical reasoning and common sense. So let's jump into the question now. All right.